Hello, everyone. Welcome. So I'm here with the review for the final exam. So this is our second review for the final. So let's work on a couple of examples. These are the type of questions that you'll see in the final exam. So you need to know how to solve the question from different modules of these types. So here is our first example for today. Let's see what it is asking. The percentage of students at a college that have internet connection at home is 80%. Okay, 80% of students have internet connection at home. Okay, in a random sample of 152 students, what is the probability that more than 38 have the internet connection at home? Okay, let's see how we can solve a problem like this one. So first of all, what they have given is, this is the question on proportion, you know it because it has a percentage in it, okay? So in general, the percentage of student at a college that have internet connection is 80%. So the value of P is given. You can see 80% is the value of P. So I can write P equal to 0.8 or 0.80. And the value of Q, that means the value of Q will be 20% or 0.2. In a random sample of 152 students, so this is our sample size, okay, sample size N is 152. What is the probability that more than 38 students, so here we are talking about 38 students, so that's the value of X. So if I want to find this proportion, X out of 152, so your proportion, sample proportion is 38 out of 152. Okay, 38 out of 152. So if we simplify that, 38 divided by 152, that's a 25%, which is 0.25. So 25%, okay, 25% have the internet connection at home. We have to find the probability that more than 25% have internet connection at home. Okay, so one more time, see what's going on here is, in general, 80% have internet connection at home. That means P equal to 0.8, Q equal to 0.2. We surveyed 152 students. We have to find the probability that more than 38, that means in terms of proportion, it is 25%, right? More than 0.25 or more than 25% have internet connection at home. We have to find that. So because this is the question on proportion, first thing we want to do is we want to check what is N times P and N times Q. Here, N times P is, your N is 152 times P is 0.8. So that is equal to 145.6. And then N times Q, that is 152 times 0.2, that is equal to 30.4. And you can see that both these values, N times P and N times Q, are greater than 5. So this implies N times P is greater than 5 and N times Q is greater than 5. So what we know is, if this is true, then according to the central limit theorem, okay, the distribution of the sampling proportion is normal. So by central limit theorem, the distribution of sample proportion is normal. Okay, distribution of sample proportion is normal. So what I'm going to do is, I'm going to draw this normal sample proportion here. Let me draw it quickly. Okay, suppose that is my diagram for the distribution of proportion. That means P hat along the x-axis. Okay, we have P hat along the x-axis, and this will be a normal distribution. Normal distribution with the mean mu sub P hat and standard deviation sigma sub P hat. Okay, so that will be, because this is for the proportion, so we have the mu sub P hat as a mean and sigma sub P hat as the proportion. So now what we are going to do is, we are going to find those two values, using the formula. Now, what we know is mean of the distribution of proportion is equal to P, which is equal to P is given in the problem 0.8. And then sigma sub P hat, the standard deviation for this distribution, is the square root of P times Q over N. So if we plug in the values, P is 0.8 times Q is 0.2, N is 152. And we can simplify this. So if we simplify this using calculator, you should get 0.0324. So if I want to write the mean is in the middle, mean is 0.8. So here I can have 0.8 in the middle. We want to find the probability that more than 38 students, that is more than 25%, have internet connection at home. So if this is 80%, 25% will be somewhere there, okay? 25%. So let me draw that. So maybe that is 25%, 0.25. We want to find the probability that more than 25% have the internet connection. Okay, so you can see that this 0.25 is on the left. It's far on the left. From here, we have to go all the way up to positive infinity. That is the probability. So let's see. Hence, the probability that the proportion is greater than 0.25 is equal to find the probability, okay, to find the probability or area, we use normal CDF. Normal CDF, lower boundary 0.25, upper boundary we go to infinity E99, mean 0.8, standard deviation 0.0324. So if we simplify this in our calculator, you can check it. This value is approximately 1. Approximately 1, because it is almost the total area, okay? Because it is almost the total area. So if you go to several decimals, then you should see 0.999. Otherwise, it is approximately 0.1. So that is the first example for today. So this one is on a proportion. Now let's move on to the next example here. So we have a second example here. Let's find out what is given in this second example. Look like this is the problem on binomial probability distribution. I can see some of you are entering the virtual classroom here. Welcome. Okay, now this example is on a binomial probability distribution. So let's find out how we can solve this. So the question says, a binomial experiment with the probability of success P equal to 0.88. So they have given the probability of success P equal to 0.88. That means the value of Q will be, okay, value of Q will be 1 minus 0.88. 1 minus 0.88. And if you simplify that, you can subtract using your calculator. So 1 minus 0.88 will be 0.12. Okay, probability of success is 0.88, probability of failure is 0.12, and the number of trials is 6. And what we are asked to do is, what is the probability that the experiment results in 4 or fewer successes, or exactly 3 successes? And you can see that this is the binomial experiment because you have the probability of failure and success the same throughout the experiment, and the number of trials are fixed, and you always have the 2 outcomes. So this is a binomial experiment. What I'm going to do here is, instead of solving part A first, I'm going to show you how to solve part B first, so that it's easy to solve part A after that. So now let's look at part B first. We have to find the probability that the experiment result in 3 successes. So this is x equal to 3. Probability that x is equal to 3 is how much? We need to find this. Now, because this is the binomial probability distribution, we can use the formula for binomial probability. And the formula for binomial probability is like this: probability of x successes is equal to n factorial divided by x factorial times n minus x factorial multiplied to p to the x multiplied to q to the n minus x. So that is the formula. So we are going to plug in the values to that formula for probability that x equal to 3. So when x equal to 3, wherever you see x, you plug in 3. And you know the value of n is 6. You also know p and q from here. So if we plug in, we have n factorial in the numerator, n is a 6. So 6 factorial divided by x factorial, here x is 3. So 3 factorial. And then we have n minus x. N is 6 and x is 3. So 6 minus 3 is a 3 factorial. That's one way of doing it. The other way is, if you know the first one, that number plus how much is this number in the numerator. If you get a 3 here, 3 plus 3 is a 6. So that's how we know that. Multiplied to p, okay, times p is 0.88, 0.88 raised to x, that's a 3, times 0.12 is our q, raised to n minus x. You can see in the formula, n minus x is here and also here. That means whatever number is here, we have the same number as a power there. So here is a 3, so that must be 3. Also remember, when you know the first number here, the sum of the exponents should also be 6. 3 plus 3, 6. Values in the denominator, that should also be 6. That should be always equal to n, the number of trials. So now, probability that x equal to 3 is equal to, now we can type this in our calculator. Remember, to get the factorial, you have to do math probability. And let me check it in the calculator, math, then you go to probability and number 4. Okay, that's how you can type it. So students here in the class, you can also type it. Let's type this together and find out the value. Okay, let's find out what you get. I got 0.0236. Is that what you get in your calculator? Please type it in the chat. Okay, that is correct. Mr. M. I don't know who is Mr. M. I can see your name as Mr. M there.
It's Brooklyn McCoy, Professor.
Oh, okay.
Sorry about that.
No worries. That's okay. I'll continue to call you Mr. M today.
All right.
Yeah. Okay. Yeah, you got it right. That's correct. So that is the probability that x equal to 3. So when x, number of successes is 3, that is the probability. Now let's look at B. Part A. I did B first. So A now. So in part A, the question says we have to find the probability of 4 or fewer success. So probability that x is less than or equal to 4. That is the meaning. Okay, 4 or fewer successes. So this is equal to, meaning of that is, you want the probability that x equal to 4 plus probability that x equal to 3 plus probability that x equal to 2 plus probability that x equal to 1 and probability that x equal to 0. That is the meaning of that. Okay, 4 successes, 3 successes, 2 successes, 1 success, and no success. So that is what we want to find in part A. Because it is OR, so we have that addition rule. So we have this formula. Now, what I'm doing here is, just to save the time, we know how to find something like this one where I'm pointing. Probability that x equal to 3. We did this math and we got that value. Similarly, if we plug in 4, we get the value. Similarly, if we plug in 2, 1, and so on, we should be able to get the value of the probability. So I'm just going to write this down. If you plug in x equal to 4 into this formula, you will get 0.1295. Plus, when you plug in x equal to 3, we already got the value here. When you plug in x equal to 3, it is 0.0236. When you plug in x equal to 2, if you plug in x equal to 2, you will get 0.0024. Plus, when you plug in x equal to 1, you can see the probabilities are kind of decreasing here. So you'll get 0.1, 2, 3, 4 zeros and then 1. See, very small probability when you plug in x equal to 1. And finally, when you plug in 0, x equal to 0, you'll get 0.5 zeros and then 3. 1, 2, 3, 4, 5 zeros and then 3. So you can see that the value is really small there. We are getting very, very small value there. Okay, so now we can add all this in our calculator. So once we add all this in our calculator, you can check it. I got 0.1556. So that is the probability of 4 or fewer success. So remember, in this problem, although I did it very fast here because I didn't show you the actual calculation, I just show you how to find the probability when x equal to 3. It's that number from here. But you have to do all those calculations, add them together, and you will get that value. And one more time, we are just using the probability formula, which is up here. We are using that probability formula to solve the problem. And in the exam, the formula sheet will be provided to you. So it should not be very difficult for you to just use the formula. Any question before we move on? Mr. M and Gavi. Any question, Gavi?
No, I have no questions, Professor. But during the test, if we get the question that says, for example, 4 or fewer successes, that is going to entail a large amount of calculations in the calculator, right?
Exactly, that's
So
true.
you did that before you didn't just come up with those answers off the top of your head.
That's a good question because, I planned it before I came here. So definitely, I had all those answers ready. So I just wrote them down. But yeah, it will take a little bit of time when you have to find all those values. Yeah.
All right.
Yeah. Okay, if you have no question, Gary, any question? I don't know if you can hear me, Gary. If you're muted, you can unmute yourself and talk. Okay, anyways, now let's move on to next one here. So here is the next one. Maybe this is interesting. Let's find out. Suppose that a random sample of 17 adult male has a mean height of 69 inches with a standard deviation of 25 inches. Okay, so the sample size is 17, as you can see, 17 adult US males. So that is your sample size. They have the height of 69 inches. That is the average height, mean height. So that is the sample mean, X bar, with a standard deviation of 2.5 inches. So the sample standard deviation is 2.5 inches. Now, if we assume that the height of the adult male in US is normally distributed, we have to construct the 95% confidence interval for the mean height. So this is the problem on confidence interval. So if you remember, in confidence interval, what we do is, first of all, we need the point estimate in the middle. Because here we are talking about the confidence interval for the mean. So mean goes in the middle, sample mean goes in the middle. And then to find that interval, okay, 95% confidence interval, we want to conclude with 95% confidence that the mean lies between these two values, lower value and upper value. So to find the lower value, we do mean minus the margin of error. To find the upper value, we do mean plus the margin of error. So we need to find the point estimate, which is already here, 69. Then we need to find the margin of error. Also, you know that margin of error is given by the formula. In this case, let me check with Mr. M here. In this problem, we have standard deviation of the sample given. Population standard deviation is not given. So is the distribution Z distribution or T distribution?
It's going to be a Z distribution.
Because the sample standard deviation is given, it must be T distribution. Okay. Yeah. Because the sample standard deviation is given, it's a T distribution. So margin of error is T critical multiplied to sample standard deviation divided by square root of N. That's what we know. So the value that goes in the middle, we already know that's a 69. So I'll write it here. Sample mean 69. We have that. Let me bring this down here. Okay, there we go. And then that is the formula for the margin of error. I'll write it here for now. Okay, so what I need is, in order to find this margin of error, if you look at the screen carefully, we have this S. S is already given in the problem, 2.5. And we know it's 17. But we don't know what is T critical. So we are going to find the T critical by drawing the T distribution. So let's draw the T distribution. Remember, in this type of problem, the drawing is very, very important. So this is the T distribution with T values along the x-axis. And for this one, the degrees of freedom is equal to, because for the T distribution, you need the degrees of freedom. Sample size is 17, so the degrees of freedom must be 16. And the middle area is 95% area, because we are looking at 95% confidence interval. So let's show that middle 95% area here. So that much area in the middle is the 95% area. So this area is 95% area. This is 0.95 or 95% area. So the remaining area on the tail is the 5% area. And that 5% is divided into two parts. That means you have 2.5% on each tail. 0.025 on this side also 0.025. And the value here is the T critical. That is your T critical. And in order to find this T critical, okay, in order to find this T critical, because this is the value along the x-axis, okay, because this is the value along the x-axis, T critical is equal to find the value along the x-axis, we use the inverse T, and we need the area to the left of this T critical. Here is T critical. Area to the right is 2.5%. So area on the left is 97.5%. or 0.975. Because if you look at it carefully, here is T critical. From here all the way up to here in black is 95%. And after that here in red color is 0.025. So the total is 0.975. And we need the degrees of freedom, that's a 16. Okay, 0.975 comma 16 inverse T. So you guys can now type this in your calculator and tell me what you will get. I'll be waiting here for 30 seconds for the T critical from you. Inverse T.
I got a 2.1199. I guess that would be rounded up to 2.120, maybe.
We can go to 4 decimal places. So 2.1199, that's perfect. Okay.
Okay, that's appropriate.
Yeah, that's good. So that is the T critical. T critical is 2.1199. Very good. So that's the T critical. And the reason we are calculating this T critical is to find this margin of error here. So now we'll plug into this equation here to find that margin of error. So if we plug in T critical, we got 2.1199 multiplied to S is 2.5 standard deviation of the sample divided by square root of N is 17. So now you can again type that in your calculator to see what you'll get. 2.1199 times 2.5 over the square root of 17. And tell me what you'll get. Okay. So I got the value in the chat. That is wonderful. So that's 1.2854 when you round it to 4 decimal places. That's correct. So 1.2854 is the margin of error. Now remember, once we get the margin of error, to find the confidence interval here, where I'm pointing, as you can see on the screen, to find this value, what you have to do is you have to do 69 minus that value, 69.1.2854. So if you do that, make sure you type it in your calculator and check. So 69 minus 1.2854. That will be the lower boundary, this one, this value. That is equal to, I got 67.7146. Okay, that is the lower boundary. And upper boundary is here. It is the mean plus the margin of error. So this one will be mean is 69 plus the margin of error 1.2854. So that will be equal to, what I got is 70.2854. So that means with 95% confidence, okay, with 95% confidence, we can say that the mean height lies between these two values. So let's write that. 95% confidence interval for the mean height, for the mean or the average height is from 67.7146 up to 70.2854 inches. The unit of height is in inch. So that is the confidence interval. And we can say this with 95% confidence. Okay, any question on this example? If you don't want to unmute and speak, you can also type it in the chat. If you have question or if you don't have question, either way. Okay, look like there is no question. So let's move on to next example. So this one is the example from Unit 7 on confidence interval. The previous problem we did, which was on the binomial probability distribution, this was from chapter 5, and this is from chapter 7. Now let's move on to next one. You can see this is a long question here. And this is on hypothesis testing. So let's first read the problem. A coin-operated drink machine was designed to discharge a mean of 7 fluid ounces of coffee per cup. Okay. So that was supposed to be the mean, right? The average amount of coffee discharged by the machine should be 7 fluid ounces. So that is how the machine was designed. Now, in order to test whether that machine is doing that or not, in a test of the machine, the discharge amount of 18 randomly chosen cups, so they are collecting the coffee or they are getting the coffee from the machine 18 times. So n equal to 18. N equal to 18. 18 randomly chosen cup of coffee from the machine were recorded. And they found that the sample mean and sample standard deviation, both sample here, sample mean, sample average was that much. Okay, and the sample standard deviation is this one. That's your S. Sample mean 7.19 and sample standard deviation 0.28. If we assume that the discharge amount are approximately normally distributed, okay, is there enough evidence to conclude that the population mean discharge differs from 7 ounce? So what we want to test here is, we want to test is the mean not same as 7, different from 7? That's our claim. And we want to test this, okay? So is there enough evidence to conclude that the population mean differs from 7 fluid ounces? And we have to use the 5% significance label. 5% significance label, alpha is 5. So that is given to us. Now, let's solve this one in next page here. Okay, we'll solve it here. You can see that in the problem, they don't ask us to use the confidence interval method or the critical value method or p-value method. So what I'm going to do is I'm going to solve this using p-value method. Okay, I'm solving this using p-value method. So the first step is to write the null and alternative hypothesis. But we have already seen that in the problem, we have mean not equal to 7. And we know from here when there is not equal to, that is the alternative hypothesis. So let's write down the hypothesis. Here, mean for the null hypothesis, mean is equal to 7. And for the alternative hypothesis, mean is not equal to 7, which is also our claim. And you know that in the null hypothesis, we always have equal to sign. Now we need to know whether this is one tail test or two tail test. Clearly, you can see there's not equal to sign. So this is two tail test. This is two-tailed. And you have to tell whether this is the z-test or t-test. And if you look at the problem here, sample standard deviation is given, S is given. If the sample standard deviation is given, the distribution follows t-distribution. So this must be t-test. Okay, so this is two-tailed t-test for, we are talking about the mean. So this is the two-tailed t-test for mean. That's your first step. Now, once we do this first step, we have to find the test statistics. But before we move on to test statistics, do you have any questions so far?
Yes. Can you please go over one more time how we know this is a t-test as opposed to a z-test?
That's a good question. So if you look at the question here, if you read through the problem thoroughly, what you don't see is the population standard deviation is not given. Is that right?
Right.
Because they have only given, you can see here, the sample mean and sample standard deviation. Sample mean is this, sample standard deviation is this. So they have given the information about the sample. Sample standard deviation is given, but the population standard deviation is not given. So if the population standard deviation is not there, it follows the t distribution, so it is a t-test. Does that make sense?
Yeah. So if we had population standard deviation, this would be a z-test.
That's correct. So if there is population standard deviation, given in the problem, that will be the z-test. Yep. Any other question from Ross or Gabby? Okay, that's good. No question. Okay, we have this first step. Now let's go to the second step. In second step, we'll find the test statistics. So the test statistic will be the t-value here, because we are working on t-distribution. So the test statistics will be the t-value, and the formula was sample mean minus the population mean divided by sample standard deviation over the square root of the sample size. That is the formula. So the mean x bar, sample mean, if you look at the question here, the sample mean is 7.19. 7.19 minus the population mean. You can see here in the null hypothesis, that's a 7 over the sample standard deviation that's given here in the problem is 0.28. 0.28 over the square root of the sample size, and the sample size was 18. Now we can simplify this to get the test statistics. So you can type this in your calculator to check it. What I already got here is 2.8789. Make sure you verify this. So the test statistics is 2.8789. So now, once you get the test statistics, next step in the p-value method is to determine that p-value. So we are going to draw this t-distribution and find that p-value. So let's draw the t-distribution. Okay, suppose this is my t-distribution with the degrees of freedom equal to 17 because the sample size is 18. And we also know that this is a two-tail test, meaning of that is the rejection region is on both tails. So we are going to show that on two tails like that. So this area on the tail, area on the left tail plus right tail, the total area is the p-value. So that means on each tail, you have half of the p-value. So this is p divided by 2, and this is also p divided by 2. And the value that goes here where I'm pointing is the test statistics from step 2. So that value is 2.8789. And once you have this value, we need to find this area on the tail. Okay, we can find the area on the right tail and double it. So the p-value will be equal to, now the p-value is equal to, let's find the area on this right tail. So to find the area, we use CDF. In this case, it is a t-distribution. So it is going to be TCDF, TCDF. And for this area, the lower boundary is 2.8789. Upper boundary, it's going all the way to infinity. As you can see from here, we go all the way to infinity. So E99. And the degrees of freedom is 17. And once we get this value, we have to double it because the total p-value is the area on the right tail plus the area on the left tail. Or you can find the area on the right tail like this and double it. So make sure you try this by typing it on your calculator. I got 0.0104. Make sure you type and check that. Okay, once you get that value, yeah, that's correct. So you guys are getting the same value as I am, which is wonderful. Okay, once we get that value, that's the third step. See, we did the hypothesis on the first step. Second step, we got the test value. Third step, we got the p-value. Now, fourth step is to compare this p-value with the significance label alpha. If you look at the question, alpha is 0.05. So we are going to compare that. So here you can see that the value of p, which is 0.01, and the significance label is 0.05, you can clearly see that the p value is less than alpha. P is less than alpha. And what we know is if the value of p is less than alpha, we reject the null hypothesis. So null hypothesis is rejected. Okay, null hypothesis is rejected here. So the null hypothesis rejected, meaning of that is, I can go here, all the way up here. This is the null hypothesis that is rejected. So I'll cross that out. So that means we are going with the alternative hypothesis. So we are going with the claim. So claim is true, but the null hypothesis is not true. So the conclusion for this one is there is enough evidence to support the claim that the average is different from 7 ounces. The machine that was designed to discharge actually 7 fluid ounces of coffee is not discharging the 7 fluid ounces of coffee on the average. It's different from 7. Okay, so there is enough evidence to support that claim at 5% significance label. So we can say there is enough evidence to support the claim, and the claim was mean is not equal to 7, and we are doing this at 5% significance label. So there is enough evidence to support the claim that mean is not equal to 7 at 5% significance label. So that is the end of this long example on hypothesis testing. But remember, in the exam, if we see question like this, it will not be open like this. Instead, there will be 5 parts. In the first part, you have to write this. This will be part B, where you have to find test statistics. Third part, you have to find the p-value, part C. Fourth part, you have to compare the p with alpha, and then you have to state the conclusion. That's the last part. So the question will be already chunked so that you don't have to remember those steps. You'll be able to just answer the question part by part, and in turn, your whole problem will be solved as you complete those 5 subparts of the question. Okay, before we go to the last question for today, any question on this example? You can unmute yourself and speak, or you can type it in the chat. Either way, I'm fine. Okay, look like there is no question. So are we ready to move on? Are you done copying this? Gabby, are we done copying this? Okay, good. Mr. M is done, Ross is done, Gabby is done. Very good. Okay, we'll go to the last example. Here we go. So this one is on the last chapter, that is the correlation and regression. So let's find out what is given in the problem and what we're asked to do. Following is the bivariate data. So 2 variable data, that's the meaning. You have the X variable and Y variable. So that's why it is called the bivariate data. Answer the following questions that follow using the data set. Okay, and answer the question using calculator. You are using calculator to answer these questions. these three questions. So what I want you to do is quickly grab your calculator and under list 1, plug in those X value, and under list 2, plug in those Y values. Okay, after you enter the data in the calculator, what I want you to do is go to stat. Let me write up here. Go to, first thing is enter data in the calculator. Enter data to L1 and L2. That's what you do first. And then second step, go to stat, and then go to calculate, C-A-L-C, calculate. Okay, and then number 4. And then number 4, where it says linear regression AX plus B. And then quickly check that in the calculator, X value is in list 1, Y is in list 2, it should be correct. There is no frequency, we are not storing the equation here. Just hit calculate. And then once you hit calculate, let's check these values. Let's see. Gabby, please type A in the chat. Mr. M chat, type B in the chat. And Ross, type R in the chat, please. Gabby, please type the value of A from your calculator. Mr. M, value of B. And Ross, value of C. Okay, I got the value of A from Gabby. It is, okay. I'm writing these values here. From calculator, Gabby sent me negative 0.5417, which is correct. I got the value of B from Mr. M here, 8 point, is it 8 point? Yes, 8.6306, 6306, very good. And then what is the value of R, Ross? What do you got? Are you still typing in your calculator? Still working on it, okay. We'll wait here for a little bit. Okay. The correct value must be, I got your value. The correct value must be negative 0.8995. 8995. That, there we go, correct. That's right. So that's the value of R. R is negative 0.8995. Okay, we got these values from the calculator. Now, what we're asked to do in the first part is, in part A, we have to find the correlation coefficient. So for part A, the value of R, the correlation coefficient is R. Okay, correlation coefficient, that is R. We need the value of R. And from calculator, you got R equal to negative 0.8995. Okay, value of R is negative 0.8995. And 0.89 is fairly close to -1. That means there is a strong relationship between the variable X and Y. But the relationship is negative. That means when one value is increasing, the other one is decreasing. When X values are increasing, Y values are decreasing. So that is the meaning. We are asked to interpret that. So we can say there is, let's write this down. There is a strong negative correlation. Negative correlation. There is a strong negative correlation between the X and Y variables. Because in the problem, they didn't tell us what is X, what is Y. They just gave the values. So we can say there is a strong negative correlation between X and Y variables. So that is your part A. Now in part B, let's find out what we need in part B. So in part B, we need the equation of the line of best fit. Okay, equation of the line of best fit. And in general, we write the equation of line of best fit like this. We write it as y hat equal to ax plus b. That's how we can write the equation. But we have the values, so we plug in the values. So y hat is equal to a. You got the value of a from the calculator, which is negative 0.5417. So negative 0.5417x. And then we have the value of b, plus b is there, b is this one. So plus 8.6306. So that is the equation of the line of best fit. Or that is the answer for the second part. Now, finally, in the third part, let's see what we are asked to do. In the third part, we are asked to estimate the value of y when x equal to 5.5. So that means if we plug in 5.5 into this equation, what is the value of y? But check one thing, whether this 5.5 lies in the given range. The range of y values are from 1 up to 9. So definitely 5.5 falls in this range. So definitely estimation is possible. So let's plug in and find out. Y hat is equal to negative 0.5417 times 5.5 plus 8.6306. And if we type this in our calculator, or if we simplify this using calculator, we should get 5.6513. So when x equal to 5.5, the y value is 5.6513. So that's how we can solve problem like this one using calculator. So we use calculator to solve that. That's from our 9th module, which is linear regression and correlation. Okay, any question on this example? Just type yes or no in the chat. Or if you have a question, you can unmute yourself and then speak. Okay, no question there, which is wonderful. Finish up your writing. Okay. Yeah, good luck for your final exam. That's all from this review for today.